In the industrial world, a power outage can make or break a company. In an article by Jay Teresco on preempting electrical power outages, he states that the seriousness of a power outage to an individual company varies by industry and application, ranging from serious and disruptive to serious and life-threatening. Now, these serious power outages that he's talking about are an unplanned power outage, when something fails, the system goes down and you weren't prepared for it. We can also conduct a planned power outage, where we, for a small amount of time, purposefully shut down the system. We maintenance the components, we test them, we acquire data from those tests, and it'll help us predict when a failure is going to happen before it actually happens. Now, I'm the senior electrician at a place called the Green Bank Observatory in Green Bank, West Virginia. We're a large radio astronomy observatory. We're home to multiple telescopes, multiple buildings, high voltages, low voltages. My job is to keep all of these systems up and running and healthy so that we can do our number one job, which is science. Now, to keep everything up and running, I have to be able to test my components, make sure that they're healthy. And when we're testing components, I could be testing everything from cables to switches to a transformer. But today we're going to talk about specifically transformers and how a preventative maintenance plan can help the lifespan of those transformers. Now, preventative maintenance is very important for the lifespan of the transformer, be that through general maintenance or through testing so that we can graph the lifespan and predict a failure before it happens. In an article by R. Peltier on preventative maintenance, he states that the real challenge isn't so much determining why failures occur, but rather eliminating them by using methods designed to accurately assess the health of a transformer and predict its remaining life. Now, predicting the remaining life of these transformers is very important. When they go down, it can be a big problem for the company from a productive standpoint and from a safety standpoint. Now, when these transformers, if something happens, it takes a long time to get one. You can't just go out and buy a transformer. Transformers take multiple months. Most of the time they're custom made. These are very large pieces of equipment. They're very expensive, and a lot of times it can be 6 to 9 months before you can even get a new transformer. Plus you have to install it. There's a lot of downtime, a lot of lost science time in my work if something goes down and I wasn't prepared. So I do two main types of tests. Besides general maintenance. And general maintenance is cleaning of the transformer, checking torques of the bolts, making sure my cables are correct, making sure nothing has gotten in there to mess anything up. Besides that, the internal workings of a transformer, we're testing the windings. Now, the windings have an insulation around them, and if the insulation fails, then the transformer fails. So I stress the insulation with high voltage tests, and then I take data from there, and I can accurately plot and predict mathematically what the lifespan of this transformer is going to be. I also, on very high voltage systems, we have transformers where the windings are submerged in a type of oil. So annually or biannually, depending on the transformer, I take a little bit of this oil and we run it through tests, and we can see if there's impurities in the oil, new impurities. We can tell if there's been a chemical breakdown or any kind of chemical change that's going to lessen the lifespan of this transformer. Once again, by the tests, I plot it on a graph, and I can visually, mathematically see if there's a downward spiral, a downward trend. And before that trend gets to a critical point, I can have a plan in place to replace this transformer, and then that way we do not have an unplanned power outage. Now, to properly do this kind of testing, you have to have a preventative maintenance program set up. We can't just go out and be shutting things down whenever we want to. We have to have this type of work scheduled. We have to have a plan for this type of testing. And in a 1998 article by J.P. Block on plant maintenance, he says it is extremely important that a single individual or position be clearly accountable for preventative maintenance development and implementation. Where I work, I've developed the plan. I know it by heart. I know when I'm going to shut something down. I let my co-workers know a year in advance before I'm going to shut something down. That way, there is no downtime that they're not planned for. They know that there's going to be downtime. I shut it down. I do my job so that they can do their job. Now, a lot of times this can create some controversy. Now, why is that? Well, no one wants to shut something down, shut down production for a small amount of time if it's working properly. A lot of people don't understand that these type of components can fail. They're not built to last forever. Nothing is built to last forever. It's going to fail at some point. So you have to be ahead of the game before the failure occurs. So trying to convince someone that I need to shut a telescope down for 3 hours 3 times a year to test different components on that is a big deal, because they're losing time, they're losing money. But it's a lot less money than they would lose if we had an unplanned power outage and then they're down for 6 months versus 6 hours. So from my experience, I schedule a shutdown well in advance. I'm prepared. I have a plan. I let anyone that's going to be working on the system know when I'm going to shut it down. Typically, I can shut something down for 3 hours, do my maintenance, gather all my data, and the system's back up and running. This is the proper way to do a preventative maintenance plan. Everything has to be logged. I have catalogs. I have, we do stuff on the computer. I also have hard copies that anyone can go in there and take out my data and see. They can also see the trend, a downward trend or a steady trend. Sometimes it's good for my company to understand that, hey, everything is working properly. Versus sometimes it's, hey, this is going to fail. We need to gather some money. We need to have a plan, and we need to get the component before we have a serious problem on our hands. So at the end of the day, the main thing to think about is it is much more productive and cost effective to have a planned power outage versus an unplanned power outage. So I hope this helps you in the future. I hope you understood a little bit more about transformers, and I hope it helps you in case you're in the position that I am and you got to try to talk somebody into letting you develop a preventative maintenance plan. Don't get caught in the dark. Make sure you have a planned power outage versus an unplanned power outage.